Thank you, Quentin, and welcome everyone to the webinar. So we're going to jump in pretty quickly through the slides because I really want to get to the demonstration with Hira, because a lot of people have been asking how to build a bot and what they need to do to walk through that. So we're going to take you stepwise through that. Before then, we're going to jump into a little bit of overview about Lex, just to level set everyone on what the service is, what the value is, so people understand exactly about what we've recently announced. Customer use cases, we'll be walking through how enterprises are using Lex to build out customer service, help desk, and DevOps support for their internal and external customers. And hopefully we'll finish up in time for a little bit of QA. So Amazon Lex is a conversational engine. It helps you build conversational interfaces directly into your applications, and that means either voice or text. We don't differentiate between voice or text in that the engine can provide both. And often we see applications that want to switch between one or the other, for example, going into hands-free mode. So building it through both of these channels is often an attractive option for customers building their bots for their employees and their customers. Amazon Lex is built on a number of core capabilities. The most important, I think, here, and we'll jump into a lot of these throughout the presentation and the demo, like things like business logic. The scale, of course, is something you get to know, familiar with a managed service from AWS. But I think the most important thing here to call out is really the speech to intent. The ASR, the speech recognition engine in Lex, and the NLU, the natural language understanding engine, these are capabilities shared across the family, the Alexa family, as well as Lex, and they're integrated tightly into the API. So what that does, it gives you very high accuracy. So we'll talk about intents and slots and utterances and ways you can customize the conversation such that your customers have a seamless, natural experience. What's important about Lex is that it uses those components, and with the ASR, it searches for speech within those components, so it gives you a much higher level of accuracy. I'm going to jump through a couple of these slides and get down to really what are the core building blocks of Lex. Lex is built on a series of core components. The conversational app that you build is a series of intents. So that's the first very important thing to understand. That is the building block that we are building inside this bot. The intent job is really to perform an action. Once the response has come in from the user input, then the action the intent will kick in, and it will fill the slots, it will recognize utterances, and it will then fulfill the action as designed. So the intent performs the action, while utterances are the phrases, the exact phrases that your customers are going to say. For example, I'd like to book an appointment. Now, this is when we train a bot with utterances. We use several ways to say the same thing. And what that does, it builds a language model. It trains the language model so that when an end user speaks an utterance that doesn't 100% match with what we typed in, we'll still have a high quality recognition event. And so we'll be able to understand that and then assign that to the intent and therefore follow the flow. So you don't have to get it exact with your utterances that you build into each bot, but it does, the more the better helps you. Slots are simply the data that's required to fulfill the intent, and we'll walk through these during the examples. Well, fulfillment is, of course, the mechanism through which the intent is fulfilled. So if we focus on three use cases, these are very popular use cases that our customers have been building with Lex. And the first one is really about internal help desk, where they want to provide a productivity gain for their employees, file time off, for example, a paid time off system there, or booking a conference room. So this is a case where we would, if we look at how this would get built, the design of the bot would look something like this. We would have a welcome intent, and then the intents that we have three intents in this case: time off, conference room, expense report, and of course you could have many more. What's important here is recognizing when the user says file time off as the utterance, that we recognize that, associate that with the time off intent. And so the utterances that we have built into that intent might be record time off, I will be out, different dates. And by the way, these dates don't are not hard-coded. You put them in as slots. So you elevate slots into the utterance itself and make it a lot more dynamic. Add PTO in July. And you can see the slots there that we are fulfilling, that we need to fulfill the intent. We do need the dates, of course, a start date and end date for a time off event to be recorded. Similarly, with a conference room, you need to know the conference room list. And so you will create a custom slot there with the name of the conference room, and again, the date and the duration of the event. If we look at another use case, this is where customers, developers are building customer service bots to improve the engagement with their customers. So for example, this is again via voice or chat, upgrade your plan, schedule an appointment. These are two different examples of how a customer would request service from a company, and then a service bot built by Lex would be able to fulfill that. So if we look at the flow of design here, once again, the welcome intent, and then with the upgrade plan, the utterances that we have, similar to how we described before. Change plan to premium, can you upgrade my plan? I think a point to note is when a customer asks something that doesn't match or can't be matched to an intent, that will go in, that will be recorded as a missed utterance, and you have a full monitoring and analytics console within Lex that will enable you to identify those missed utterances, and you can also promote them back into the intent. So by doing so, you're constantly improving the quality of your intent. If we look at the DevOps bots, now these are an interesting use case that we've seen a lot of interest in, and really the ability here to take action internally, support the DevOps, the operations teams as they engage with processes that are normally very administrative and mundane, but very easy to build into a bot infrastructure. And so we can see a couple of examples there when we're updating the trouble ticket, the information we need to know, the sort of conversation we'd have, what state you want to put this in, roll back a code change similarly. So by streamlining the operations and the efficiency of those operations using a bot, this is the sort of design again that we would come up with. So once again, we have the intent, and we discretely have those assigned to like update ticket intent, rollback intent, deploy intent. Again, you could build a whole library of these intents within this DevOps bot. And so if we look at the utterance, can you update a ticket? And these are the utterances that we've used to train the intent with. And then the slots, again, the ticket number and status list. So once again, you can customize those slots, put lists, your own lists in, be able to validate against those lists. If we look at the design of the bot, we just did, sorry. If we look at a very important part of designing a bot is the context. And so one thing about Lex that is not immediately obvious, but it's super important, is how we continue information, bring it through into the bot, into the infrastructure so that that data can be retained. So the slots, of course, are data gathering devices, and prompts are used to ask for the data to fulfill the slots. For example, what time would you like your appointment? But we also capture session attributes. So in any way that the application passes session details, session information to the bot when it's being called, those will be preserved and can then be reused. And that's really important. In the case, for example, if you're asking for, if a sales manager, for example, is asking to show me my sales in the report in the US East region, and the next question was show me my top customers in that region, what's important is we've already captured the region from the previous slot. We have the session attributes as well. So a combination of all these things go to making the next turn in the conversation a lot more accurate and fulfilling, much more natural to a human flow. Conversation flow is also critical because humans don't always just want to flow through the path that we define for them. So we have two different ways of branching and chaining intents. And so what you can do here, the important point is that you're always in control. So in the first case, you see we have a conversation where it gets to a question, dine in or take out. And if it's dine in, then the previous intent or the existing intent just keeps going. If it's take out, then we can switch. And this is where the power of Lambda comes in to make these easy switches from one intent to another one to follow the path the user wants to take. And so that makes, again, a very natural conversation flow. Chaining is think of it as a follow-on, where you can, when you've finished one intent, then you can suggest another one. For example, I've booked a hotel. Would you like now to book a car? So it's a very common phrase that you see in a travel scenario. So we're going to pause here and jump to a demo where we've got Hira on deck. So we're going to take a few moments to switch across, and then we'll be back with the demonstration.
Hey everyone, my name is Niranjan Hira, and I'm hoping to show you how you can build a Slack bot with Lex. There are some really good examples in the documentation, so I'm going to take you there to begin with so that you can see that it's not just Android or iOS apps, but also other messengers that you can integrate Lex with. In fact, the whole idea here is to make it easy for developers to bring the power of natural language understanding to your applications. So these are the steps that you might want to follow through on your own when you're working with Lex. As an example, we're picking on a Slack bot today that is one that's near and dear to me as a developer. So at some point as a developer, you've been asked to log your hours in whether it be Jira, whether it be Bugzilla, or name a system of your choice. And I think it'd be really helpful if you could ask Slackbot to do that rather than have to click around and find the tasks that you're currently working in. So let's talk first about the steps that would be involved, and then let's take a look at a quick demo. So first, of course, you'd need a bot, and we'll go through building one of those. You'd obviously need a Slack account and a team that you work with. You can create a Slack application, and when you create that Slack application, it's important to remember these steps actually walk you through it. So I'd suggest you follow them after this webinar. You ensure that you're using the right features, namely that your user is tagged as a bot user and that you set it up to receive interactive messages. And then let's take a look at what it might work as, and then we'll take a look at the work involved in Lex itself. So here we are talking to our Scrum Bot. And as a developer, again, I might ask a question like, what's on my plate today? And we'll see that different developers can certainly use different messages to reflect this. And our Scrum Bot returns with, well, here's the list of issues that have been assigned to you in Jira. As you might guess, there is in fact a Jira API in the background, and thank you to the kind people who actually created this using Node.js so I could quickly put this prototype together. What we see here is, as you might guess, with Slack, the ability to put together links. But Lex also allows you to create response cards, so you can take one-off actions with these issues. But all we're trying to do here is to say, I just want to log 2 hours on one of these issues, right? So we're just going to say, log these 2 hours. And then the bot can turn around and say, well, what would you like the working comment to say? And famous last words from any developer, I'm almost done, right? I just have to refactor this one last thing. So what you'd expect in the background is for Lex to take this information and post it back to Jira. So let's see if that worked for us. So here was the issue in question. We're seeing an instance of Jira that I've been playing with for this demo. And you can see that in its original state, the work log was empty. And I'll just refresh the page so you can see what it looks like once we were done. So as you can see, we just logged 2 hours. And you can see that the comment was also added to this ticket. Now, what else could you do? Well, you could certainly do things like reflect who else is working on a task, or what are the open tasks. You could ask about whether somebody has taken a look at this thing and whether there's a comment from this person. It just depends on how far you're willing to take the bot. The truth is that there are bots like this today, and they are incredibly useful. But the idea here was to see what it would take to do this with Lex. So let's talk a little bit about that. It's easy enough to build a Slack bot. So we talked about what it takes to build a Slack bot with Lex. What I'd like to do is to show you what the Lex side of this integration would look like. So when we first start with Amazon Lex, You can start with an existing bot, as I'm showing you right now, or it's more fun to start with a new bot, knowing that you've got some intents available to use. So let's start there. So we're going to create a new bot. We're going to call it Scrum Bot B or something like that. We're prompted to choose a voice. In this particular case, we're not going to use voice. We're just going to use text. There's a default session timeout. David earlier alluded to session attributes. The Lex voice or interaction session is similar to a web session in the sense that you can use this bag of attributes to keep track of other things that you want to maintain in context as the conversation continues. This IAM role is something really cool that Lex does. It actually manages the least privilege that needs to be made available to the bot on your behalf. We're not working with minors here, so we'll just say that. And when we first come here to the intent editor, we're prompted to create a new intent. Now, like a cooking show, as it were, we actually have intents that we can work with. So let's say the intents that we saw today were the list issues intent, and I'll talk a little bit about why we did it this way. So in the first case, what we wanted to do is to say something along the lines of list my issues. And as you might guess, most users would say things a little differently. So I might say what's on my plate, somebody else might say just show me my issues, somebody else might feel the need to just make it work with LS. But the list of utterances there isn't intended to be a complete list of absolutely everything your users say. It's intended to be a list that is directionally correct so that the network has enough data to build a good example for you. So the first intent was to list issues. The second intent is to log work, and this is the more interesting of the two intents. So in this case, again, we start with utterances where we say log, and we're choosing a slot, time spent, on an issue number. An issue number, as you can see, is a custom slot type. And a custom slot type is a slot type that you can use to provide custom data. It is always preferable to use one of the existing slots. So where possible, for performance as well as for fidelity, it makes sense to use one of the existing slots. Having said that, there are times when there just isn't one that's built exactly for your needs, and the issue number is one of those examples. So it makes sense to provide not an exhaustive list of every single issue number, but rather a representative list that can be used to build a network, a model. So as you can see, we have issue numbers that are similar to 3 or 4 character project name and 2 or 3 digit issue numbers. The other slot that's interesting, the slot type I should say, is this comment. Now what's important about comments is if you're not careful with the types of data that you provide, a comment may not be understood in context. So you do need to provide sufficient examples so that, again, a model can be built on your behalf. As an example, a comment that has to do with a bologna sandwich may not necessarily pass muster for this model. So it's important to provide sufficient data that can be used to find comments that match. So with those done, we can choose duration, and Amazon duration is a slot type that allows you to, for example, say that this meeting is going to go on for an hour, or it's scheduled for 4 hours or a full day, and those kinds of things. And if you know the ISO standard around this, it represents data in the PT1H type format. So what we're doing here then is once we've chosen these slot types, we can also choose these response cards. Prompts. I was jumping ahead. You'd like to have Lex choose the prompt that it uses to keep the conversation from becoming monotonous. It's important that you provide that information up front so that you can maintain spontaneity. So as an example, we have a type that says, we have a prompt that says, what should the work log comment say? Then we have another prompt that says, what comment would you like to use for this entry? And what we'd like to have Lex do is to choose between those two at random so that the conversation with the end user isn't apparently monotonous. This number, the maximum number of retries, specifies how many times Lex tries to understand a slot value before it gives up. And you could specify the utterances that it uses. You could also, if you're familiar with building Slack bots, you can create choices with buttons using Lex. One of the advantages of doing it here is that you don't have to distinguish between the kinds of syntax that Slack uses versus the kinds of syntax that Facebook uses. Lex takes care of that for you, and you can see the preview in different forms here. So once you're done building these intents, you save them one at a time, and then you can build your bot. And it's suggested that when you first build the bot, you work without any connecting Lambda source. And what this allows you to do then is to spend more time working on the Lambda once you know that the language model actually works for you. So while our bot is building in the background, let's take a look at that Lambda. So there are plenty of Lambda blueprints around this. It is helpful to certainly look at those blueprints, but let's take a look at the one that we're using for this little bot. As you might imagine, there are a collection of API wrapper functions around Jira. So we pass information along to Jira, and we have some kind of a switcher or router that takes care of integrating with Jira for us. So in this Lambda function, what you're now seeing is that intent dispatch, and it is the main router. It isn't a good pattern to put all of your Lambda in one place, but the reason we use this kitchen sink is it makes for a really good illustration of some of the things that you can do with Lambda around Lex. So remember that Lex manages the conversation for you. So when you don't really have a reason to customize the dialogue or the flow of the dialogue, you can just let Lex take over. But on the other hand, you could use these callbacks to have Lex do something specific. So let's take some examples. In the documentation, you can see this response format, and this is a good way to learn how you can tailor the dialogue. You can have Lex do things like confirm the intent to say, hey, are you sure you wanted to do this? Or delegate to Lex, say, I really don't have anything specific to do. Let Lex choose what the next step would be. Elicit intent to say, the user's done something. I've done it for the user. As an example, I've logged these 2 hours that you asked me to do. Is there anything you'd like me to do after that? You can choose to elicit a particular slot. So as an example, you could say, I didn't understand what you were saying with that work log comment. Or, for example, in your work log comment, you mentioned a particular other user. Would you like me to notify that user as well? So going back to our Lambda, you make these callbacks with code like this. And you can certainly localize your strings by taking them out of this code here and placing them somewhere else, getting those from a messages bundle of some sort. You can certainly pull them from a DynamoDB database as an example. And this is an example of delegating back to Lex. So in this particular example, because we have no slots to look at, we can simply delegate back to Lex to say, I don't have anything specific for you to do. Do what you would normally do. So going back to our bot, and remember, this bot isn't connected to anything. We saw the connected version working with Slack. But in our current state, this bot is simply going to return parameters to client. And all that allows us to do is to see if our language model works as we expect. So imagine as a user, instead of saying list my issues, if I simply said my issues. The question is, does my bot understand that well enough to come back to say, you meant list issues? And in this case, as you can see, it is ready for fulfillment with this list issues example. And on another example, you can see that we said log a certain number of hours on this issue number. So let's say we say just that. And we'll use a bogus issue number. We'll use a bogus comment. And as you can see, Lex comes back and says that it's ready to fulfill. It would have passed along the following slot values to Lambda. It would have passed along the time spent in this format, the ISO format I was referring to earlier. It would also pass along this issue number, HAM99, and this work log comment. Now let's take a look at some of the other settings that we can manipulate. So you can increase or decrease the session timeout. Session timeouts, remember, are important to maintain context. You can also choose to set up aliases, and in fact, you'll have to set up an alias to publish to Slack. And let's see Slack associations here. So when you create an application in Slack, recall that you get, on the basic information, you get the information that you need, the client ID, the client secret, and the verification token. You use these in Amazon Lex to create an association. So it's a little hard to see with this new bot. Let's take a look at the one that's already working, and you'll see what it looks like when it's done. So in this case, this is our working bot. You can create multiple associations. In fact, you can use the same Lex bot against multiple channels. You can also create multiple Slack bots and have them go against the same Lex bot. So our Scrum bot that was posted to an alias called QA, and an alias allows us to have different versions of this bot running around. Remember, Lex was built for developers. So making the rash assumption that you're not going to push everything that you've just built to production, Lex allows you to specify the alias that you want to use and make publicly available on this Slack association. So when Slack uses this OAuth URL and this postback URL, and that event API pushes those events, those are made available to a particular version of your Lex bot. So let's take a look at the aliases here. And you can see that our bot is currently at version 6. And this is an important thing to realize, because what winds up happening is you can create an intent that is shared across the AWS account and therefore might be in use by other developers. You can also create slot types that are equally shared. And you can also create bots because of these Slack associations that are shared. And so what you'd want to be able to do is to use these aliases to ensure that your end users are in fact interacting with the correct version of the bot that you intend. With that, I just want to say thank you for your time.